follows me around. All right, guys. So I've had a few questions I've answered already. Does anyone else have questions? And then I have a couple things I want to do some examples of. Anyone have any other specific or general questions?
Can you go over number 9 of the practice test in chapter 3? I'm having a little issue with the algebra.
Let's see. All right, let me share this. Chappelle. So this one here?
Yes.
Okay. All right, this is a good one. Can everybody take a minute, unless you don't want to, it's up to you, and give this a try, this number 9 here, if you haven't tried it already. And of course, Jason's like, well, dude, I'm pretty sure I'm talking to Jason right now, right?
Yeah, you're talking to Jason.
All right. I couldn't remember. I was like, dang it, whose name did I see highlighted a second ago? You can sit and wait for a minute. So what I personally like to do is, I try to tell you guys, the people that do this naturally have the easiest time in mathematics. And I'm going to make this plea. You don't have to. If more of you could turn your cameras on, that'd be great. If you can't, I understand. You don't have to. Oh, look at that. There's people. All right. I love it. I feel more like I'm talking to actual people. I break this problem up. I would say, okay, what's f of b? So what's f of b?
It's going to be 3 minus 2b squared plus b.
All right, and then, of course, f of a is just going to be the same thing, just with a's in it. So this one didn't really necessarily need to be broken up, but just to remind you guys, break the problem up into parts. So now I got to do f of b. Dadgummit. Pen. That's right, Jeff. Blame it on the pen. Minus, now here's the part where people make a mistake right off the bat. Somebody's chatting at me. Let me see. I can't handle everything. Oh, sure. Okay. That's fine. Thank you for that. Oh, I see. Yes, you are. Okay. Glad I didn't wear mine. I would have been. And then that's going to all be over b minus a. So let me stop for a minute. That's not the problem you had there, right? You it's okay if you did, but I mean, is that where you had the problem? You forgot the...
No.
Okay,
I worked that all out. It's when you start to eliminate items and then the recombination and separation to get your BA so you can cancel it out and stuff like that.
So I actually was working with somebody. As I write this down, let me know anybody that has a problem with anything I've written down. Let me pick a color. That's kind of light. Hold on. Somebody's, there we go. There's a dark green. Oh, okay. Somebody's telling me they have the same problem. Is everybody cool with what's happened so far? So f of b, f of a, I subtracted them. You have, and this is a line I drew because the 3's cancel. 3 minus 3, and then the negative has to go through, and the negative has to go through. Okay, so that's just some preliminary little hurdles to get over. Here's something you could do. Do you see something very related to this on top? Anybody?
Yes.
I see it, don't I? So that tells me how to kind of consolidate this. Let me move this stuff around like this. Because that is already going to work well with this. Okay. Somebody else chatting. I love you guys. Oh, yeah, there you go, Jasmine. Okay. Keep this open somehow. Let me stop there for a minute. Is everybody with me on what I've done so far? Why can't I just go ahead and kill these? And that's my answer.
Because it's added into the negative 2b squared plus 2a squared.
Division is not allowed to break into an addition. Everything has to be divided by this. So of course, do you see why I did this? I've identified this part doesn't need any work. This part needs work. What work can I do to this part?
Factor out.
Yeah, what do you factor out? I'm going kind of backwards here just because of my space.
You can factor out a -2 or 2.
Yeah, you definitely want to take a -2 out because then that makes the B positive, which matches up with the bottom. So you see how you can think a little bit ahead as you do stuff to make things easier later. So if I take a -2 out, I get B squared minus A squared. And I still got my B minus A over there. And I think that's where I'll stop. Or is that, did you have trouble after this?
Yeah, it's after that. Because I've gotten to this point, but do you continue to factor out? Excuse me.
That's what you do with this.
Yeah, you just split them up so that's -2 times B minus A times B minus A plus B minus A.
No.
See, that's...
I mean, what form is it? This is a difference of squares. There's no way that the sign in the middle can be the same.
So plus A.
It's got to be, right?
Right.
Make the middle terms cancel, make this minus A squared. And now the next mistake people make is they'll still like kill this and somehow this guy's left alive. But notice what you can do. I've done more than I wanted to, but you can obviously factor a B minus A out of the top, or you can just kill it, as long as you kill it everywhere. Now, if you kill this and this, what's left up here? So I can kill this and I can kill this. What's this minus itself? I mean, this divided by itself. That's right, 1. Okay. There's a few different ways to do that problem, right? I mean, I could have went, instead of doing this canceling out, I could have taken a B minus A out, and then I would have been left with -2 times B plus A plus 1 all over B minus A, and then these really die, right? And you're left with this business. So I did the problem for you, damn it. I just can't stop myself. Oh, this is a practice thing anyway. Who cares? That's right, Jeff. Good point.
Thank you. I see where I screwed up.
And always, the specific problem we're working on at the moment doesn't matter worth shit, right? It doesn't, because I'll bet you so much money that you will never see this exact problem, not that one, this exact problem ever again. Right? I'd be willing to put money on it because something's going to be different. It might be the same thing, except there's a 5. There's, you know. So what's most important is, why did I do the steps that I did? Why? What was my motivation? Because then you want to make that your own motivation. You have to determine what the next step is, and very often the math is trying to tell you what the next step is. When you notice stuff like the B and the A match with this, let me move them to the side. Now I know to work with this. I mean, if I didn't do that step, I wouldn't really know what the hell to do with anything. Okay, maybe. Okay, anything else, guys? Did anybody else try out some of that stuff? That is really weird. I don't know what that is. That is weird. Sorry. I got this pen thing that I'm writing with. It's got a little button on the side. I have no idea. Oh, yeah, I do. It's if I want to use it like a mouse. Okay, I got it. Everybody else is okay? Any other questions? Homework, practice test, anything? No. All right, so what I wanted to do, I'm going to ask some questions for you. Mr. Waller, can we do more transformation problems? Yeah, that's a good question. So let me find some. I'm going to stop sharing so I can easily clear that. There's got to be a transformation problem in the practice test. Let me see. Is there? No? That's weird. find F inverse. All right, so I'll just, it really doesn't make any sense.
Number 13 makes you graph some transitions or shifts.
Thank you, thank you. All right, so let's take a look at these two. All right, so let's take a look at number 13. What's the base function I'm working with number 13? Does anyone know what I mean when I say that?
Square root of x.
Root of x. I like it. I heard somebody, but it was very faint, and then I heard somebody else. So of course, how many shifts are there in this?
2.
I'm sorry, say it again.
2.
2, yes. All right. So when you're doing the work for this, do not make an XY table for this function. That completely invalidates the whole point, right? We're trying to learn shifts. We're trying to learn applying transformations. So one thing you can do, one way to do this kind of problem is to list out the transformations. What would this do?
To the left 6.
Good, left 6. Because when it's in with the x, when it's in with the variable, it does the opposite of what it looks like. Because, let me say this again, because I really want this to get through. For this guy, if I want the same outputs from this guy, all my inputs have to be 6 smaller than they used to be. Because the first thing this thing does is add 6 to them. So please make that, so does it make sense then? It's a reaction to this. I move back 6 because the plus 6 makes up for that. So my graph can now move back 6. I don't know if that makes sense. I always get people confused. It says plus, Jeff. Why the shit aren't we going up? Well, because that allows all my x's to be 6 less. And then what's this guy do, of course?
Down 1.
Just to remind you guys, isn't 13 also, I could write it like this. Can you guys still see that if I go over there?
Yes.
I just brought the y back, right? And can't I add 1 to both sides? If I wanted to. You don't have to. You never have to do this. You don't even really have to understand what I'm doing right now. This is just, if you understand it, you understand the whole thing a little better. So that's with the variable. It does the opposite. It goes back 6. 6. That's with the variable. It does the opposite in this variable's direction. It's going to go down 1. Did I have to do that to see that? No, but I want to show you we don't treat this different. It's just that this isn't with its variable. That's why I can look at this as it does exactly what it looks like it does. It goes down 1. Is that helpful at all, or is that just Jeff wasting air again? Damn it.
That makes sense.
Thank you. Let me see. Somebody's shouting at me. Oh, makes sense. Okay, good. As I was opening, I'm like, this could be you're wasting air. I don't know. So now, to do this, I really need to see some kind of base function. So what's the square root of x? It goes through 0, 0. You should have some basic points it goes through known. 1, 1, and 4, 2. Those are the basic ones it does. And I always make oh shit, it would be really nice if I actually went through. There we go. So that's my base function. It's dotted because it's not the answer. Let me even change colors just to be really nifty. Do I want blood red? Sure, it's blood red. And then I can do my shifts to all my points and then just reconnect it with the shape. So let me move this. Well, shit, now I'm gonna have to go left 6. All right. 1, 2, 3, 4, 5, 6. I can do it. And then down 1. So let's go down a couple. All right. So if I go 1, 2, 3, 4, 5, 6, and then down 1. So now that point is there. 1, 2, 3, 4, 5, 6, and then down 1. So that point's there. 1, 2, 3, 4, 5, 6, and then down 1. So now that point is there, and then I connect it and done. So this is a valid work. You told me what the shifts were. I got it this, and then you can actually just apply all the shifts at once. You don't have to draw a new graph for each shift. That's one way to do this work and show me the work. I have way too many people giving me this. There you go, Mr. Waller. It's done. No, this is bullshit. Right? Hopefully nobody's offended by me saying that because it is bullshit. This is bullshit. All right. Trying to make a big deal out of this. I want to tell you this. You guys might have picked up on this. Who agrees? Who gets the sense that this course, and I don't say this to make you scared or anything. I want you to realize this course is graphing hell. We are going to graph the shit out of everything. I want you to be ready for this. Some of it, I'll show you how to check it in your graphing calculator. Some of it will actually just do in the graphing calculator. Most of it will be by hand. Why do we do that? Because what course, of course, would normally come after this course? How many times can I say course?
Calculus?
What course? Yeah, calculus, crazy. So when you get to calculus, even if you're not going to calculus, I don't care. I've got to treat it as if everybody taking this course is going there. When you get there, you want the calculus to be what you're learning, and the graphing should be just second nature. So that's what this course does. It just puts you through all this graphical stuff, different ways to look at how to create graphs, quicker ways to make graphs, so that when you get to calculus, the graphs will actually help you, as they should, with learning the extra other stuff. Okay, enough, sorry.
So
Enough.
I know I'm one of the people who I didn't do it as crappy as your red over there, but on your other graph, I didn't actually put in your dotted line graph, but I did write what shifts were being done and then give you the line. So is it safe to assume that if I put in the dotted original moving forward, that I won't get those questions wrong as long as I get the shifts right?
Yes, exactly. That's because what this does is it tells me that you connected these statements with the visual.
Right.
I see these dots. I see where they went. That tells me you can make that connection.
Okay.
That's
Thank you.
what I need. Thank you. All right. And real quick, if you're getting like every single homework assignment and I'm saying correct on it, and you're like, God damn it, very often there's just a few things too many that you need, that you got wrong, or that, you know, so it's not like a ton of stuff. And when are corrections due? Homework corrections.
Day of the final.
Day of the final. In fact, so are quiz corrections, right? I can't remember because that was something I hadn't even decided when the semester started, but I decided to make them do the day of the final also. Okay. I'm going to clear all that. Let me see. Do you guys want to see another one of those or something else?
Can we see another one of those?
All right, let me clear these. Pop. All right, now for this other one, number 14. Oh, shit. Oh, yeah, okay. Who knows what the base function is?
1 over x.
Yeah, so we're working 1 over x. Anybody know what that looks like? This is one of the functions you need to know the basic look of it. And the funny thing is, if you don't know, well, does anyone know? No, okay. So this is the most basic hyperbola. So it's going to go through 1, 1, right? 1 over 1 is 1. That's crazy. And it's going to go through -1, -1. No, it's not supposed to go through there. I can't. That's so weird. All right. So it's got asymptote there and an asymptote there. It's just asymptotes all over the place. Asymptotes all the way down. So let me see if I can't do that a little bit better. No, I can't. Okay, good to know. Good to know. Good to know, Jeff. Ah! So now I've got these two. This one I'm not going to need like crazy amounts of detail from you on this one because it's good just to know what the general shape is. So it's basically just those, I'm going to try one more time for some reason. It's just these two opposing boomerangs, right? I like that. Opposing boomerangs. Shaboo, shabao. And did anyone remember this is one of the most basic forms of a certain thing? I said this before. It's some comets have orbits like this. This is the most basic example of a something? Starts with the letter H.
Hyperbola?
Hyperbola. I love it. This is the most basic example of a hyperbola. Hyperbola. So now, if you don't know the shapes yet, they've listed them at least twice in the book. So it's kind of important to keep listing them over and over again. So now I can just apply all right, Jeff, the transformations. Oh man, I'm so ready for a long weekend. Who else is ready? You guys know Monday's a holiday, right? You remember that? Okay, I'm exceptionally ready. So what are the two shifts? What's this first one here?
Left 2.
Left 2.
Good, yes. I got a little excited there. Left 2. And then this one's gonna make it go
Down 1.
down 1. So I start, let's see if I can do this any better. You can do it. 1, 1, 1, 1. Let me cue Trey. We can do it, Jeff. What is it? Is it okay? So it's 2 and 1. Think of it. Always sucks when the shift is like 8 or something. All right. So here's my basic shape. It goes through those anchor points. Come on. Oh, I should have done it dotted. Too bad. And those anchor points, and it's got that shape. All right. Now let me change my color. And then you just apply, you take the points, you take your anchor points, and you apply the shifts to them. I don't know, I'm going for a Christmas theme. Maybe it's from the first season of Happy. Has anyone seen that? So left 2, 1, 2, down 1. So that point is now there. Left 2, 1, 2, down 1. So that point's there. Where's this asymptote go?
The -2.
Yeah, left 2, and the up and down doesn't do shit to it. It's an infinite thing going up and down. So who cares about an up and down? So I'm going to put an asymptote there. Where's this asymptote go?
To the -1.
Yeah, right there. So now I've got this, and I've got this. I even drew the walls in for myself. So get used to that also. It helps you to move the asymptotes because then they give you walls to work with. Does that make sense? I got to go up against that wall. If I didn't draw it for myself, I wouldn't know where the wall was. I like it. I should have worn my Gandalf shirt. My Gandalf shirt says, "You shall not pass," and it's got the asymptote. Anyway. I wore that to a final exam one time. So anyway, I probably shouldn't do that anymore. Sorry. Oh, it's evil, Jeff. I don't care. Is that all right? So that isn't like a ton of work. It isn't. And very often it's just a little more work than some of you guys did. So often it gets me kind of frustrated that you're so close to doing enough. And I'm like, nah, you just didn't do enough. Okay. Somebody says yes. Thank you. All right. So that's enough of that one. What's the next idea we want to go over? Let me see. What time is it? I want to keep an eye on the time. I'm probably going to stop class. Let me see. I will tell you this. This quiz ended up being 13 questions. Oh, yeah. Look at that. That's a good reaction. I like it. So I don't want to end class too long after 6 is what I'm betting on. So I actually didn't even plan on doing anything new tonight, obviously. I was just going to focus on questions. So maybe a few more questions, and then I want to give you guys, what's that, Brian? All right. I'm so behind. I don't even know how to create that in the chat box. I have no idea. You go beyond my ASCII characters, and I don't know what else going on. So any other general topics you want to cover, or does anyone remember what for sure is going to be on the quiz for certain?
Can you do one of those, oh shoot, what are they called? The graphs that like don't touch?
There you go. That's exactly piecewise, right?
Yeah, those ones.
That's fine. Yeah, I don't care if you don't know the name. That's fine.
I always want to say
sounds-
Pennywise because I read way
I
too much.
know. I was going to say it sounds like a very strange math horror movie. But no, it's not Piecewise the Dancing Function. Don't worry. Oh, I need you. Come here. So let's see. Is there a piecewise function? That would be very strange if there wasn't. There we go. There it is. So let me share this. So I'm looking at number 8 on the practice test for chapter 3. Let me see. Oops, I gotta do this again. It's too much technology. Who's chatting at me? Oh, what's up, Julian? What about today? Yes, the quiz is today. Is that the question? It was supposed to be yesterday, so we've had a whole 24 hours extra to get ready. All right, so number 8. Let me see. Let me do some blue. I'm getting tired of green and red. Give me some blue. All right. Okay, cool. I like that reaction. Oh, this one's not a very interesting. Oh, well, it doesn't matter. You want a more interesting function than this? Is this all right? Or you want some absolute values and shit?
They get hard.
All right. Let's make this problem a little different. Let's put an absolute value there, and let's put an x squared here. That's a little bit more interesting, right? Okay. In fact, let's do this. Let's do this. Let's put this, let's make this, 11 minus x squared. Okay. So are you with me? So absolute value of x plus 1 and 11 minus x squared. So you don't have to do it this way, but my big suggestion, if these are difficult, are to make XY tables. And look what else I can do for myself. Look what I can do. For the absolute value of x plus 1, what inputs am I going to use?
For which one?
Between negative 2 and 3. So
Yeah. I'm going to definitely use -2, right? And then, I mean, if I want to, I can do every single one. It doesn't really matter. But of course, what am I? I'm going to do this for myself to remind myself. Why am I going to do this around these two?
So you remember that it's not included.
Good. So I got to put open circle there. It's not included in the domain for that section, right? So now this should be too bad. Absolute value -2 plus 1, -1. Absolute value is 1. Is that all right? I mean, now when you do the work, it should be easy. That's 0, and that's 1, and that's Jeff. Keep it straight there, buddy. That's 1, and that is 2, and that is 3, and that is 4. Okay. Is that all right? So I am helping myself remember, because one thing I've noticed when I'm grading stuff is sometimes you guys don't know when to stop creating a function. It can only live between those two inputs. So when you make your XY table, make sure to plug in the endpoints and then stuff in the middle so you know that's the only place it lives. So what about this guy has only got a floor to him. He's got no ceiling, right? I don't know if you guys see what I mean when I say that. So when I make his little XY table, my God, Jeff. My God. All right. So I definitely can use 3, 4. I mean, I only have to use too much stuff. What shape is this going to be fundamentally?
Parabola.
Parabola. It's going to open
Downward?
downward 11 because this x squared piece is negative. So when I throw a 3 in, I get 11 minus 9 is 2. When I throw a 4 in, I get 11 minus 16 is -5. And then I can just put that shape on top of it. Right, so now when I go to create this, I want to go -2, -1, 0. Well, let's see. There we go. You could do it, Jeff. All right. And then what do my outputs look like? It looks like I got to go down to -5. Okay. So now I can start doing stuff. Oh, yeah. Let me put this there, too. So -2, 1 is an open circle. -1, 0, 0, 1, 1, 2, 2, 3, 3, 4 is open. So that segment, oh crappity doodah. If that happens, make the point big. There you go. So that makes sense. That segment should only live for a very brief time, poor little thing. And then the downward parabola takes over here, and it's, where is it? 3, 2. So 3, 2, and then 4, -5. So now the downward shape, it should be curved, but oh well, I just can't do it on this. Dadgummit. All right. All right, I'm going to let that go. It's going to be fun. That's terrible, Jeff. All right, I'm going to stop looking at it. Again, what's important to get here? You have got to remind yourself when this function stops existing and something else takes over, right? What if this would have been greater than or equal to 4 instead of 3? I could have done that, made it even more interesting. That would have just meant that this whole area would have just been empty. The parabola would have started at 4, -5. It would have started there. And there would have been empty space in the middle. Because I don't know, hint, hint, that might happen sometime, hint, in the future to you. Hint. Okay. How are we feeling? What time we got? I want to, okay, maybe one more question, maybe, or maybe 2 quick ones, I don't know. I don't care.
Can you
Graphing
maybe
it.
do, oh, I was just going to ask if maybe you could do one of the problems like somewhere between like either 15 or 16 from the practice test.
All right, so I got one question somebody just private chatted to me. Let me see if that matches what you're saying. I'm going to clear all my horrible stuff up there. Bam. And then you're saying 15, 16? Okay, good. So these are my last 2 questions. I have a question about, we'll do this one, and then I have a question about inverses. What is the test? What do you do to test if it's even or odd symmetry?
It's like mirrored across the y-axis or the origin, right?
And that would so suck if I have to graph these, because do you see how disgusting these are?
Yeah.
Yeah. Now okay. So this one is obviously got what kind of symmetry? The one I just wrote.
Even symmetry across the y-axis.
By definition, right? But what about this one?
I think at that point, wouldn't it be neither?
Yeah, because this is even because it's got the y-axis as a mirror. Does this still have the y-axis as a mirror? Well, no, because it's moved where?
Left.
Back 4. So it's no longer symmetric with respect to the y-axis. So somebody almost said that as an answer, and they were curious if they were wrong, but it's not wrong. You just got to make sure you get the whole thing. If you wanted to answer this question, you don't even have to show me work. Just say it's shifted left. It's not symmetric to the y-axis anymore, and I'll have little tears coming my eyes. But what is the actual test? You check this. If that equals this, even. If that equals this, odd. If that equals neither one of those, neither. Right? So so my point is, can anyone just tell me what the answer is for that without doing any work? It's got to be even because every power in there, it's not shifted, is it? Nothing's been shifted. Nothing's with the x. But if we do the test, so let me put a negative x in there and a negative x in there. And the minute you see this test, you realize the even power kills the negative. So of course it just becomes right the same thing as it was before. So that's even. The even power kills it. So what's number 16?
Odd.
Odd, because it's not shifted and the powers are odd. But that is the test. If it's not a simple problem like this, this is the actual test you do. You do this check. That's the check you do. All right, maybe. And now let's talk about inverses, and then I want to definitely stop class. It's getting almost to the point where I definitely want to stop. So everybody got what they want from all that business? Is that all right? You guys cool with that? Especially whoever answers that question. Okay. I'm going to assume that's a yes. So the person that asked me about the inverses, can you be more specific for a second? I think you meant like if I give you a graph, how to do the inverse from the graph, or do you want to do one like how to find the inverse from a function? Okay. In the interest of time, I will tell you that I did not put that kind of problem on the quiz. But real quick, that would be the problem where I give you a graph. Don't think you're never going to have to do this, by the way. Oh, I got some chats coming in hot. Let's see. Awesome sauce. Oh, yeah. Don't get too excited because then you got to think, well, what's actually on the quiz then? That's where I give you, we did a graph like this, and then we graph the inverse, and you get that neat cross of y equals x is what it's supposed to be, right? When you just turn all the points around. You with me? So actually, if I were you, I would be disappointed because that's relatively easy. Somebody. All right. I like that. All right. Any last second quick questions?
I have a question about domain.
Yes.
Is that so? Like, as in, like fog. If you have a function that's like 1 over x, and you have another function that's like g, and you like combine that, what is that domain?
Well, how are you combining them? You mean
Like
composition?
a fog, like putting the x within.
Okay.
Oh wait, I think I messed up. Or where it combines, where it's like x over x, or not really x over x, but would the domain of each one be like? Actually, I have an actual problem to ask you.
Sure.
Like, I gotta actually find it though. I was just confused on it. I threw it away.
There's a problem that ends up with x over x, and you're supposed to tell me the domain, and the domain is not all real numbers.
It won't? Okay.
Yeah, I can't remember how you get there, but you get to this point, and of course that's 1
Mm-hmm.
as long as x is not what? This isn't true
0.
for every. Yeah. So
0 over 0 is also.
No. What is 0 divided? What's 0 divided by any? This is really interesting. What's 0 divided by anything?
Undefined. I believe.
0 divided by anything
is 0.
0. What is anything divided by 0?
Undefined.
So what is 0 divided by 0? Which one wins?
Undefined. You're right.
No.
No?
No.
Oh,
Nope.
God.
It's even worse. It's called indeterminate.
Oh, I totally forgot about that word.
Well, it's okay. You're not even necessarily supposed to know that word. Most of you probably did run up against it, but anyway, it's even worse than undefined. So
I'm not touching it. I'm not going to ask you.
The point this is trying to make. So even if I had something like x minus 4 over x minus 4,
Mm-hmm.
and that equals 1, you still have to say the domain is x cannot be 4, because that's the, if x were 4, this would not equal 1.
You're right. Okay.
Yeah. Somebody's chatting. Let's see.
Sure.
Okay, I'm not sure what that means. Graph reciprocal along with the inverse. Oh, it might be, just to make sure that you understand that this does not mean this. Sure, that could be true. Somebody's sending me a private question. That might be the point they were trying to make on that problem. I can't remember off the top of my head which problem that is. Okay, I definitely want to stop class and give you guys enough time to do this. So let me make it active in Canvas. All right, where are you, Canvas? This is always good. Let's watch our teacher trying to wrestle with this technology. Here we go. All right. So if you go into Canvas right now, you'll see quiz 2 in the same place that you found quiz 1 before. You make sure everything looks good. As before, you do not need to, let me have the lady